Okay, this is question 4.6, the last question of this November 19 exam question on analytical geometry. Now, this question says, if it is given that the quadrilateral OBCD, this green thing that I've outlined here, if it's equal to 2a squared units, 2a squared square units, and that if a is greater than zero, show that a equals root 7 over 2. Well, I looked at a few different ways in the memo in the exam, and you can look at it too. They do it really complicated. But last Saturday there's a teacher who came, and he had this great way of doing it. He said, I can get the area of this green square. Let's just figure out how many square units are. And what he did is he said, let's look at the big triangle, up to 3, down to -3. Yeah, it goes up 3, and there's -3. Well, what's the area of this big triangle here? The area of the big triangle. Well, it's 1/2 the base times the height. 1/2 3 times 3. And if we take away this smaller triangle here, we'll be left with the area of the green quadrilateral they were asking for, OBCD. And how does that work? Okay, 1/2 of 3 times 3. And now this triangle, it goes from 1 all the way up to 3. That would have a base of 2. And the perpendicular distance to C here is just 1. You see, it says -1. It's 1 to the left. The coordinates of C are -1, so that's 1. So the area of the smaller triangle is 1/2 the base of 2 times the perpendicular height of 1. Well, 1/2 of 2 is 2. 1/2 of 2 is 1 times 1 is 1. This is 9.5, or 9/2. 3 times 3 is 9 over 2. Minus 2 over 2, that's 7 over 2. Well, that's a fast way of coming up with the whole area of this green quadrilateral is 7 over 2 square units. Well, that equals 2a squared. Well, if we divide both sides by 2, we get a squared is 7 over 4. And then if we take the square root of both sides, we get a equals root 7 over 2. And if a is greater than 0, there'd be 2 answers, plus or minus. If we take the positive one, it must be root 7 over 2. And that's what we were supposed to show, that a is root 7 over 2 units. So there are other ways of doing this, but this is by far the easiest way. The big triangle minus this small triangle gives you the quadrilateral they were looking for. So I hope this kind of helps. I hope it makes some sort of sense. Okay.